Hi guys, this lesson is for those people who don't understand simple derivative sketching and understanding interpreting maxima minima for optimization. So when you try to understand, first of all, maxima minima, let's say this is my curve and I want to understand how the curve is behaving in different parts of the graph. Now, when you look at the slope, as you know, the derivative represents slope. So first thing in your mind should be that always is dy by dx when you talk about is slope of the curve. Alright, so when you talk about the slope of the curve, if you look at the slope out here is positive, going to 0, negative, going to 0, and again positive slope. Now there is a very important observation that you can make is for a maximum your slope changes from positive to negative, and for a minimum slope is changing from negative to positive. So this is your local minimum, local min, and this is your local max. Why I'm calling it local? Because there might be values higher than this and lower than this. That's why these are not local. If these are the global maximum minimum, means there are no y values which will be higher than this and no y value will be lower than this. So let us try to quickly understand how can we sketch derivative curve from here. So if you look at this simple understanding is out here my slope is 0. If I draw a tangent out here, you can clearly see if I draw a tangent out here, its slope is 0. Right? Now if I draw a tangent out here, slope is 0. At this point as well. Now what I do is, first of all, I'm trying to sketch now derivative curve. So first you see wherever your curve has a maximum or minimum, your derivative must be 0 at that point. Now what we have to do is we have to kind of understand the sketching of single derivative. So first of all, if you look at this range, my slope is changing from high positive, here is somewhere very high slope, high positive to slowly towards 0, and then from 0, so let's sketch till here. So now on my y-axis I have derivative values. So what I'm going to do is from a very high positive slope coming back to 0. Now from 0 slope it goes to negative, becomes very high negative and comes back to 0. So from 0 it becomes high negative and comes back to 0. Then from here onwards, if you notice that it becomes more and more positive. So it becomes more and more positive means it's increasing, slope is increasing. So positive slope, so it's going to be something like this. So this is your single derivative curve, and as you know, you can see that the function is cubic because it has 3 roots, 1, 2 and 3. Its derivatives are quadratic. So these are kind of stupid general assumptions people make to explain, but you can clearly understand whatever we've done is so far absolutely fine. Now we have to sketch double derivative as well on the curve. So how do I sketch double derivative now? So now consider now on your y-axis you're plotting double derivative against the same x values. So first of all, now I'm forgetting the green curve. I'm going to kind of consider only the pink color curve. So what we have is we first see that this, okay, here is the point where is your double derivative graph going to cut x-axis because slope of this is out 0 out here. Now if you look at the slope out here, so slope is negative, from a high negative it comes to 0, then from 0 it becomes more and more positive. So what we do is, this is high negative slope, high negative come back to 0, then from high positive, low 0, it becomes very high positive. So this is a clear observation that we are making out here. So this is a simple procedure to understand your maxima and minima. Now let us draw some of the important conclusions. So first thing that we notice is that there are some critical points. So first what we do is we do for maxima or minima. Alright, so let's say maxima or minima. So first of all what we do is you have to kind of understand that, okay, wherever you have maxima minima, dy by dx equals to 0. Now you solve for x values. Solve for x values out here. So a simple example I'm taking is, let us say I'm taking x cubed minus 4x out here. So suppose this is my y. So if I do dy by dx equals to 3x square minus 4. So let us hang on here. Now once you solve for x, there are two conclusions that you're making. The first one is that wherever you have maximum, your first thing is your sign diagram of single derivative is changing, because you can see here it was positive and here it is negative. Or you can clearly simply see from the slope curve. So first when you solve for this equals to 0, So when I equate to 0, I get x equals to plus or minus 2 over root 3. Alright, so now I can do two ways. First one is I will draw the sign diagram for the curve, sign diagram for the values. Let's say I got x equals to a from here. You draw the sign diagram. If the slope of the graph is, take a value left side of the x and take the value right side of the x. For example, if you have x as 2, take value like maybe 2.5 this side and closer value to 2, or maybe this side, I mean this side 1.5 and this side 2.5. And if your slope is changing from negative to positive, it's a minima. So this is a minima. If slope is changing from positive to negative, it's a, if the slope is changing from positive to negative, it's a maximum. Alright. Also, if you look at the double derivative sign diagram, so if you have your double derivative, look at the maxima, and if you look at the double derivative value, it's negative. So for maxima, your double derivative has to be negative, and for minima, your double derivative has to be positive. Alright, so let us check for this question. So you can clearly see for your minima, your derivative is 0 and double derivative is positive if you trace on y-axis. So now let us talk for this question. So when you have x cubed minus 4x equals 0, we got x as 2 by root 3. Okay, 2 by root 3. So let us take a point this side of this. Maybe I could take 0. So if I'm taking 0, it's your double derivative, your derivative is negative. If I'm taking other side of 2 by root 3, which is maybe I'm taking, let's say, positive 2. So 3 into 2 square is going to be 9. Means 4 into 3, 12. 12 minus 4 is going to be 8. So here's positive. So this will be a point of minima. And your double derivative for negative 2 by root 3, let's check. So if I take negative 2 by root 3, if I take left hand side of this, maybe I could take negative 2. So negative 2, if I take, it's a positive. And if I take the other side, maybe I take 0, which is going to be negative. You have to plug in the derivative. So here if you take 0, maybe you plug 0. So it's going to be negative 4. So that's why it's negative. So it's a maxima. So I hope this procedure of finding maxima and minima is clear to you. I repeat again, if you have simple original function given, look at the derivative has to be 0 and double derivative has to be negative. For maxima, derivative 0 and double derivative negative. For minima, your derivative 0 and double derivative positive. Now the third point that is left out is point of inflection. Now point of inflection is something, it's a critical point around which the concavity of a curve change. So concavity is changing means this side is concave down and this side is concave up. Alright. So first of all, if you notice, the biggest important thing is that your double derivative curve, this curve is 0 at this point. So for point of inflection, your double derivative must be 0. So many teachers tell you that, okay, if you tell double derivative equals to 0, it means that, okay, this is the point of inflection. No, this is not. Double derivative 0, it simply means that it's a necessary condition. It's not the sufficient condition. Because if you talk about the double derivative negative, it simply means that your concavity must change. So now if you look at this side, it's concave down and this side is concave up. So you can definitely say it's a point of inflection. Also, when you look at the sign diagram of this, its sign diagram is having a different value. So if this side is having negative and this side is having positive. So what does, first of all, concave up mean? Concave up is simply your double derivative is positive, like a minimum. And if your double derivative is negative, it's like a maximum. So you can clearly see that this side is concave down and this side is concave up. So what you do is, this is the procedure. First you look at the double derivative equal to 0. Then if your double derivative is positive about that point, and you have to solve for x here after equating to 0. Solve for x. So let us talk about this example. So let us see if there is any point of inflection for this. So you do double derivative equals to 0. So now you do double derivative. So dy by dx square is going to be 6x. If I equate to 0, I get x equal to 0. So can I conclude that, okay, double derivative equal to 0 for this means that there is a point of inflection? Absolutely no. So what I do is I take this sign diagram for double derivative. So look at the double derivative. If you double derivative about 0, if you see, look at this side, if I take it side, this side positive, if I take a 1, 6 into 1 is positive, and if I take negative 1, 6 into 1 is going to be negative 6. So this side, you can see the sign diagram of double derivative is, this side is negative, this side is positive. Clearly means that this side is concave down, and then this become concave up, something like this. Not the exact shape of the curve, but this is how the curve will look, this side. All right. So as a summary, here is the summary for all of these. So when you look at the simple derivative curve, first of all, your derivative must be 0 for maxima minima. Your double derivative must be negative for maxima, double derivative must be positive for minima. You have to first of all solve for double derivative equal to 0. Either you can draw sign diagram or you can verify with double derivative. For point of inflection, your double derivative must be 0. That's a necessary condition but not sufficient condition. Concave up means your double derivative positive, concave down means double derivative negative. Alright, hope this kind of this lesson helped you, and you can solve more problems from my upcoming videos.